What I think particularly exciting with being a researcher is the opportunity to find out new things. You don't have to go back and look at something that's been written in a book, but you can actually contribute data of your own. And the moments when you are able to postulate an hypothesis and you can collect the data demonstrating that this hypothesis could be correct, and you start realizing that I now have accomplished something which nobody else knew about before, these are some of the most exciting moments in our daily life. So we are now witnessing a very large increase in the resistance of antibiotics for these pathogenic strains, and it's a very serious medical problem. What we are trying to do here in my research group is to try to understand why some of these bacteria cause these invasive and severe diseases. Because if one can determine what the mechanisms are and find key regulatory processes, one can then in the future envision that these would be very powerful and suitable targets for new pharmaceuticals. There is a lot of research going on in this field. What I think make my research especially different from others is the method that we used. So we have developed a method or a technique that allows us to measure all the proteins from a bacterium, but we can do it at the same time. This will provide us with a much more detailed picture of how the bacteria adapt to different environments, how they can avoid the immune system, but also how they interact with the human host. Traditionally, what researchers have done in the past is that you would try to look at one protein at a time, and then you try to understand this extremely complicated process. It's like trying to figure out the picture of a jigsaw puzzle by only looking at one single piece. So we have two major goals. The first goal is that we try to facilitate or help the doctors to find these very dangerous strains and be able to basically match treatment with type of bacterium. Secondly, we're trying to find new mechanisms or regulatory processes which are particularly important for the bacterium to cause these diseases. If we can identify these processes, we can now also in the future envision that we can target them with new pharmaceuticals and actually specifically knock out these dangerous strains, which is opposite what is done today, where you give this very broad range antibiotics, knocking out the entire population of bacteria, which is actually very negative because many of the bacteria that you have in your body are actually very good for you. It was very natural for me to very early on start to think about scientific projects. However, at some point I was very much interested in bringing science to products and to work as an entrepreneur, which I actually did for a number of years. And I think that's also why I can now compare the scientific research with the world of entrepreneurship. And it's interesting because there's a lot of similarities. In particular, what I think is very important is the goal and the dedication, and you need to follow your vision. There's no predetermined path of how you should do it. There's just a lot of opportunities. And just to go from A to Z and just drive yourself towards the goal is similar in these two environments, and which I also think is what makes it so much fun.